What we want to find ultimately, we want the reaction at the pin at A, and now we have a fixed support at C. Again, looking at it from the perspective of chapter 5, we're going to have 2 unknowns at A because it's a pin. And at the fixed support at C, we'll actually have 3 unknowns because it can't rotate, it can't move in the X, it can't move in the Y. A total of 5 external reactions. So the external free body diagram would only give us 3 equations, not enough for all of the reactions we're looking for. And we're told that B is a smooth pin. First thing we can try to do is see if we have any 2 force members in the picture. So here, are either of the 2 members 2 force members? The answer should be no. BC, first of all, it's fixed at C, so right away it cannot be a 2 force member, or we can't identify it as such because it's not 2 pin connections. And AB is pinned to A, but it's not pinned at B. It has a peg and slot, which is going to behave differently. So AB we cannot identify as a 2 force member either. BC also has a force along its length, so that doubly disqualifies it from being identified as a 2 force member. So we can't use any of that information to our advantage, but we can separate it out into its individual members and start to solve for some of our unknowns. So our free body diagram step, I'm going to break it into its individual components and draw their pictures. I'll start by drawing AB. We have one couple acting on it, 900 Newton meters. At A, we have that external support. We have a pin. We can model as an AX and an AY. And what do we have happening at B, where it's connected by that peg and slot to member BC? It can move along the direction of that slot. So it can move along a 45-degree angle. The peg does not prevent that motion. It can slide inside that slot. So at 45 degrees, it can move along this line. So specifically what that peg prevents is motion normal to the direction of that slot. So it's not as easy as just saying X or Y, because it can move at 45 degrees, but what it cannot do is move perpendicular to the direction of the slot. So in this case, it's a single force. It only prevents motion along the axis perpendicular to the slot. Since this is at a 45-degree angle, that means that that force, that axis that it cannot move in this direction, that'll also be at 45 degrees from the, in this case, the vertical. And so motion is allowed along one axis, but it's prevented normal to that axis. So only a single force we should be modeling at B. If we look at this free body diagram, we have AX, AY, and B. We actually only have 3 unknowns in this picture. So I would actually start solving these equations right away before I draw my next picture. It's going to make the process a little bit easier, and we'll see how that works in the next picture. I can solve for the 3 unknowns, so I'll take advantage of that and do that now. From my first picture, what equation is going to be good to start with to solve for some of my unknowns, or my first unknown? Right, moment around A, because B will be my only unknown. AX, AY are not going to be in the picture. What will my right-hand side be? From the couple, it's going to be in the clockwise direction, 900 Newton meters, which means it's imparting a negative 900 Newton meter moment at A. This is where we have to be careful. This is given to us in millimeters, which is okay, but this is given in Newton meters. So either everything on this line has to be in meters, so it matches this, or everything in millimeters, which I would have to then change this into millimeters. So instead of the 800 millimeters, I'll just convert it into 0.8 meters. Now on this one, find the moment is convenient because B is perpendicular to this line, and we know that because of the way the peg acts. We know what the perpendicular distance is the 800 millimeters, or the 0.8 meters. So I can simply say it's 0.8 times B, Otherwise, I would have to, like before, break it down into its horizontal, vertical components. Now we need to find this horizontal and vertical component and turn it into 2 steps. This one, because it's perpendicular, I can do it much easier. If this were not perpendicular to this line, then I would have to go through those extra steps. And that's all that's in that first equation for the moment. So from here, the only thing I don't know is B. So I'll take advantage of this and find B right away. I'll also point out, all I know about B is that it acts along this axis. I decided to draw it up and to the left. I could have also drawn it down and to the right. As long as, and we'll see in our second picture how this works, as long as I'm consistent, my assumption really doesn't matter. If I solve for B here, it turns out that B was in that direction 1,130 newtons. My guess is right. I could see from here it should be right because if I'm trying to rotate this that way, to resist that rotation, B would have to point up and to the left. But if I say it was down and to the right, I would have gone to negative 1130, and we'll see how that would kind of keep going in the next picture. I have my B. Either equation I do next, I'll be able to find another unknown. In the x direction, I'll have AX minus B sine 45. I can find my AX. And remember, I want my reactions at A and at C, so I do need AX and AY in this case. Knowing B, I can know that AX is 795. I drew it to the right, and it turned out it was positive, so that was correct. And finally, in the y, I'll have an AY plus B cosine 45. Since the y component of B is positive, its x component was negative. That means that AY should be a negative 795. I drew it as up. I got a negative answer. It's actually down. 2 of my reactions then I have solved, but C wasn't even in this picture, so clearly I need more, another free body diagram to get more equations. I'm only half done with things that I was looking for. But by kind of taking a break from free body diagrams, writing my equations, and then solving it, I think it's going to make the next steps easier. Already having numbers for some of these, the math portion will be easier. Now I can draw just BC. And I'm going to isolate it from the wall at C. I'm going to isolate it from that first member, AB. I have here 500 newtons. In my drawing, I'll just convert this to meters right away. That external reaction at C, it's built into the wall. As we discussed earlier, that wall prevents it from moving anywhere in the xy plane. I can't move it left, right, up, down, diagonally. I can't move it at all. So at point C, I'll have a Cx and a Cy, since all motion, all translation is prevented in the xy plane. And being built into the wall, it's also not able to rotate at point C. So there's also that couple that the wall imparts on this member. And in my notes, I called that MC. Once again, arbitrarily, I'm just going to assume CX, CY are in the positive, along the positive axes. And I'll assume that MC is counterclockwise, and it's okay if I'm wrong. I then have to model what's happening at B, that internal connection between members. Ignoring any of the math I did so far, I have to make sure that I'm matching or respecting how I did in the first picture. In this picture, I said it was up and to the left, which automatically means in this picture, I have to draw it down and to the right. Again, that's regardless of if it turned out this was a positive or negative number, it doesn't matter. This picture has to be complementary to the first picture because they have to be equal and opposite in the 2 pictures it appears in. So it has that same value B, but in this picture down and to the right. And I know that's a 45-degree angle. Any questions on that second free body diagram? And we see what happens if we started with this picture. It's not wrong, but starting here, I would not at that point know B, CX, CY, or MC. This would have 4 unknowns in it. So when I was drawing my free body diagrams, had I drawn this first, I probably would have just kept going and then drawn this one and seen that this picture has only 3 unknowns in it and started my solution here, just because the equations starting there gave me numbers right away. So it really doesn't matter where you start, but once you see one that has only 3 unknowns in it, probably you want to start writing the equations from that as soon as possible. Moving on to my picture number 2. Now that I do know B, because I started up in picture 1, it doesn't really matter if I start with moments or forces. I'm going to be able to solve for the 3 remaining unknowns from any one that I start with. So I'll just start with the forces in now picture 2. I have CX. And then in my picture, I'll have B sine 45. Now I can put in the value I know for B. It does turn out B was positive. So that means that the last remaining unknown in equation 4 is CX. And CX turns out to be negative 795. Double check that. Yes. Negative 795. I arbitrarily said it was pointing to the right. It's negative, so it's actually pointing to the left. In the y direction, I'll have that applied force down, Cy up, and B cosine 45, that adjacent leg is pointing down. It's pointing in the negative y direction. Again, I know B, so Cy is the only unknown in my equation number 5. For Cy, I get 13, I believe it's 1,300 newtons, pointing up. But I want all the reactions at A, all the reactions at C. So I can still take a moment equation. So in this picture, where should I take the moment about? C. Right. I would probably normally say C. I think actually in this case, B is a little bit less work. Most of the time, a pin is the best choice, but it's just going to be a pain to do a sign there. So I'll take it at B, and we get the same answer. So if I take it at B, then B does not appear since it's off at that odd angle. And by now, I know the value of Cy. So I'll have a negative 0.6 times 500. I'll have plus 1.2 Cy, which now I know, plus MC. If we have a couple in the picture, it doesn't matter what point we take the moment about, that couple will appear in the equation, and the couple is never multiplied by a distance. So I took the moment around B, but I still have M sub C here from that couple. Had I taken the moment around C, that M sub C would have still been there and been the same value. So since I know Cy from equation 5, equation 6, the only unknown I have is MC, the couple that the wall exerts onto the member. So in that case, MC, I assumed it was counterclockwise. I actually get negative 1250 Newton meters. This is another point where it's important to make sure all of your units are consistent. I changed everything here from millimeters to meters. So now here I have newtons times meters. Cy was in newtons, 1.2 is in meters. That means that my couple will then be in Newton meters as well. So negative 1250 Newton meters. I assumed it was counterclockwise. That means it's actually clockwise.